Hello, Professor. My name is Youngjin Kim, a second semester student and the integrated master PhD student. So today, in this video, I'm gonna give a presentation related to my research. I'm researching for open vocabularies in understanding using hierarchical knowledge guidance in visual language models. Existing research on open vocabulary scene often struggles to make a correct judgment when faced with ambiguous category names. To solve this problem, research papers define relation for each object, which has led to many performance improvements. But they still define relationships with simple modifiers, which do not fully describe all categories. Therefore, I thought that if I could find a way to describe the relationship better than these simple modifiers, I could describe the various categories more completely and improve the related performance. The figure below illustrates the point. One example of an ambiguous category is polymorphous words, which often leads to difficulties in detecting objects because the model has to decide which meaning to adopt. Therefore, I can say that hierarchical knowledge guidance helps us to define the relationship between objects, which help us to accurately determine and detect objects. Therefore, I have summarized a few related papers to materialize this topic. The first paper is my key paper, and this paper was published in XAI in 2024, which introduced a hierarchical prompt tuning method that integrates both structured and traditional language knowledge from LML and applies these methods to the vision language model to improve performance by enhancing the prompt effect. Let me explain the method. First, they use an LLM with two different instructions to generate a description and structured graph for a class. They then feed the description and structured graph as input to the fixed text encoder and the hierarchical proper text encoder, respectively. The bottom left figure shows a pipeline illustrating the process where the text encoder on the left is fixed and only training the prompt encoder, while the image encoder on the other side is fixed and training the hierarchical proper text encoder. Through this process, they are integrating structured knowledge with traditional linguistic knowledge and modeling them stimulously to improve performance on several benchmarks. And let me explain the conclusions. The method proposed in this paper improves prompting effectiveness through hierarchical prompt tuning and shows performance improvements for both base classes included in training and new classes not included in training, as shown in the experimental table on the bottom right. In particular, the performance improvement for new classes on the visual language model is noteworthy. The following is paper published in Europe in 2023, which proposed a new approach to overcome the dependence on pre-aligned visual language space by reformulating the alignment between region and words as a co-occurring object detection problem. Method to explain the overall framework and process in the bottom left. They first group image and text pairs according to the shared concept in their captions and then identify objects and shared concepts that co-occur as pairs of regions and words. Then they find co-occurring objects by utilizing the region correspondence between images through similarity between regions, and then refining the similarity between regions using text guidance to find a co-occurring object. After that, they calculate the weight sum of region embeddings to form a prototype, and then proceed with training using binary cross entropy loss. Through this process, they formed an alignment between region and words, which significantly improved the detection performance of various benchmark tests. So conclusion, the method proposes this paper introduce a novel approach to aligning regions and words by exploiting the co-occurrence of image-text pairs. They have also shown that it can be used to run object-level visual linguistic alignments for web code image-text pairs in the open vocabulary domain. Finally, they demonstrate the strength of their method by achieving good performance on the open vocabulary object benchmark, as shown in the table at the bottom right. Next up is a paper presented at ICCV in 2023, which aims to improve zero-shot action recognition by fine-tuning a visual language model using a collection of labeled videos and a set of language sources. Method: first, given a collection of labeled videos and a predefined action dictionary, they construct a text bag for each video from different language sources. By text bag, it means a collection of potential text descriptions for each video, and also performed multiple instance running to run from labeled videos and noise data text bags. Where multiple instance running is a technique for handling cases where labels are not directly assigned to individual instances, but rather instances are provided as a bag. Conclusion: they proposed MAXI, an approach that leverages a collection of unlabeled videos and a set of language sources, and demonstrated that it outperforms a pre-trained backbone in zero-shot and few-shot experiments. It is particularly noteworthy that it outperforms the supervised pre-trained backbone in very limited scenario, which is noteworthy. Next is a paper presented at CPR in 2024, which proposed a new transformer based in real-time object detection model, RT-DTR, to address the performance and speed degradation caused by handcrafted elements like NMS. While existing DTR models are capable of detecting objects without NMS, their high computational cost limits their real-time performance. To solve this problem, the author designed the RT-DTR model to overcome the shortcoming of DTR while achieving performance that exceeds existing real-time detection models. Method: as shown in the overall figure on bottom left, RT-DTR first designs an efficient hybrid encoder to quickly process features at multiple scales. This hybrid encoder separates intra-scale interactions from cross-scale feature fusion. This reduces the computational cost by more efficiently combining features containing high-level information to run conceptual features of an object, enabling the next stage of the decoder to accurately predict the location and category of the object, which significantly improves the real-time processing speed. They also introduced a query selection mechanism when many were uncertainty to generate high quality of queries to combine feature maps of different resolution and finally fuse them into a single feature map to optimize decoder performance. This mechanism improves on the traditional simple classification, score-based query selection approach to provide a high-quality initial query that stimulously considers the object, location, and class information. Okay, conclusion. In this paper, they first proposed RTDTR, a real-time end-to-end object detector that does not require handcrafted elements such as NMS. And our contribution includes the design of an efficient hybrid encoder to handle multi-scale features by separating within scale interactions and cross-scale features fusion as described in the previous method. And the introduction of uncertainty minimizing query selection to provide the decoder with high quality initial queries, which improve both speed and accuracy. Next is paper presented at CFR in 2023, which proposes a novel approach to address the problem of distributional mismatch and the difficulty of detecting objects in new categories when applying traditional image level classification model to the task of region level detection. So, method, as illustrated with the overall figure on the bottom left, they first introduce a mechanism called region prompting to improve the region features extracted by clip image encoder. By adding runnable prompts for each object features during the training process, region prompting ensures that the features extracted from the image as whole are reflected consistently at the region level. This ensures that models trained at the image-wide level can effectively address the problem of poor detection performance at the region level. They also improved the clip-based regional classifier by using the anchor pre-matching technique, which pre-matches the query and class embeddings of each object. It enabled stimulus object location prediction and class recognition. Anchor pre-match first forms an anchor box based on the object queries and compares it with the preset class, embedding to correspond to the most appropriate category. As a result, the model is able to run generalized object localization even for new categories, which significantly improves the detection performance for new categories in various benchmark tests. Okay, conclusion. The core method proposed in this paper utilize two core techniques, vision profiling and anchor pre-matching based on clip to overcome the limitation of image-text pre-training models. In particular, it achieved excellent performance on COCO and ELVIS benchmark and demonstrate high detection performance for novel categories in comparison experiments with various visual language models. Finally, they demonstrate the strength of our method by outperforming existing methods in open vocabulary object detection, as shown as in the table at the bottom right. Next is paper highlighted the 2024 CVPR, which introduces a novel cost aggregation-based approaches to tuning visual language models for the complex task of semantic segmentation. Okay, method. The first computes the cosine similarity between image and text embeddings, aggregate the spatial and class costs, and apply them to clip to effectively segment both seen and unseen classes. The bottom left figure 2C visualizes the segmentation of cost volume through spatial and class aggregation. Here, the clip and the fine-tuned clip still have a wide distribution of background noise, but the aggregated cost effectively surfaced the background noise, resulting in a well-defined segmentation of target classes. Conclusion: the framework proposed in this paper applied the cost aggregation method of spatial cost and class cost to clip to improve the performance of the open vocabulary semantic segmentation task. In addition, as shown in the bottom right table, the MIOU scores were significantly improved for various datasets, demonstrating the effectiveness of the cost aggregation method in achieving higher segmentation accuracy. So today, I gave a presentation related to my research. I'm trying to find these related papers and apply them to my research so that I can find and improve the current problems in field of open vocabulary object detection and write a paper on it. Thank you very much.